So today the focus area would be we go more deep into symmetric key encryption. Okay, and plus today we also go move deep into, I can say also start the topic called hashing. Okay, this two topic is very important because without knowing these two topic, it is very harder to understand PKI. PKI means public key infrastructure. That will be my next day plan. Maybe next day will be tomorrow. And then we talk about TLS and SSL handshaking. Okay, and then only you can move your HTTP to HTTPS. Okay, and whichever the area you want to work. Okay, in the terms of anywhere you want to make it, the thing secure or data secure, this part we need. And it is not only for authentication. Also, it is not only for the encryption purpose. It is also useful for the authentication. What is authentication? How different from encryption and how it's going to useful in my next class I will talk about, right? But before we go in this topic, or before we go to a topic called how to create your own CA, how to create your own root CA, sub CAs, and how to issue a certificate that's called CSR, then we convert to CRT. Okay, lots of things is there, right? But before I go in this topic in very detail, okay, and try to create an infrastructure of public key, means secure infrastructure by the help of cryptography, the way we have in Google, where we have in the Facebook, where we have everywhere, right? We go to Google, everywhere have the secure infrastructure. What I show you today, every connection is been secure, right? And it is not only about application security, is not only about mobile security or network security. It is about, if you go to blockchain, if you go to any cryptocurrency, you go to NFTs, Web3, the cryptography is a beast. So even though if you go for VPNs also, they also use this kind of secure tunnels. That's called IPsec tunnel or secure tunnels or proxy tunnels. Everywhere this security is gonna help you, right? So cryptography is a beast foundation, what I was trying to tell you yesterday also. Okay. So today, guys, we'll move deep into some algorithm in very detail. I can say in the symmetric key algorithm, right? So I told you yesterday, if you want to want encryption, okay, encryption means you're converting your data or plain text data in such a form that nobody can understand, but they can read. Okay, but without understanding, the data is not useful. That's called cipher text. Okay, so if you want to convert your data into this, it's called encryption. And if you have the encryption, you can also roll back, means you can also decrypt. Okay, so it's a two-way. Encryption is always the two-way. Means you can encrypt, and after encrypt, you can get back your data. That's called decrypt. Okay, but there's one concept called hashing. Okay, and hashing, guys, there's always one way. So what are hashing? What are one way? Why is useful? Where it is useful? Where hashing is useful, especially in the blockchain or in the authentication world or some other world called integrity, checksum or checking or digital signatures. Hashing is very, very critical topic. Okay, so we're gonna discuss there. But what I was discussing yesterday, if you want to do encryption, there's two way we can have the encryption. One is symmetric and one is asymmetric. So asymmetric, guys, topic I will discuss, and at this point in time where we discuss SSL and TLS handshaking in my maybe next class, maybe tomorrow. Okay, but right now I would like to go more deep into symmetric algorithm. Okay, and for doing all the practicals, guys, almost all the practicals, okay, we are going to use a tool or the command that is available in all the operating system, or you can install in any of the operating system. That's called OpenSSL. Okay, so if I open my Windows prompt with the typing CMD, okay, in the Windows also by default, I believe they have OpenSSL, or you can go for OpenSSL and download this command. Okay, so in my Windows, I have this command already with me. Okay, so rather than I will launch my Linux operating system, where I show you yesterday, we can run the OpenSSL respective thing practice in my Windows and Mac also. Okay, but whenever I need my server, Linux server, I will go to my AWS cloud and get the server over there, right? So let's do the next thing. Let me exit from this tool right now, and let's then do the next thing in my command prompt, right? So what's the plan for today? Okay. Guys, today we are going to discuss one of the very critical topic that's called modes. Okay, in symmetric encryption. Okay, we have a different kind of mode that's called cipher mode. Okay, so if I talk about, there's a multiple modes we have. Okay, some of the mode is very famous, very useful. Okay, some of the mode, if I give you the name very quickly, they are known as operational mode, or I can say this cipher symmetric encryption mode. So there's multiple mode. Some of the famous mode that we have is called ECB, that we're going to discuss today. One is called CBC. One is called CFB. Okay, one is called OFB, and one is called CTR. So these are some very famous mode we have. We have much more mode, but these are some mode that we are going to discuss today. But to go for this mode and to understand this mode, I have to first explain you, okay, how some of the modern symmetric algorithm work. Okay, for example, AES. This very, very powerful algorithm in today's world. Almost everywhere, from banking to everywhere, we use this algorithm. But to understand this algorithm, we have to I have to explain you first what is DES algorithm. Okay, and before I start DES algorithm, I have to explain you in parallel these modes. Okay, every board has their own limitations, benefits, and depend upon the requirement and use case, we are going to use these modes. And guys, again, there's no prerequisite for today's class. I'm going to explain the thing from very basic, the way we have discussed in the last class. Okay, but if you very quickly check, okay, in the Google, that in the cipher mode of operation, something like this. So this may be one link of the Wikipedia you can see. Okay, and the cipher, or cipher means your cryptography, can think about, or can think about encryption. Okay, we have multiple different modes. Okay, one of the more called ECB, CBC, CFB, OFB, CTR, what I write over it. Even though we have some more, but these are very famous mode we have, and I'm going to elaborate this mode in very detail. But there's one more terminology here. If you see what is IV, okay, there's one more terminology here called key. What is block size? What is padding? Okay, or what is stream cipher? So these are very, very important terminology, guys, in the encryption world. If you don't know this terminology, then working security field with pure wastage, or anything you want to customize in your secure environment and secure world, it won't work. Okay, so by the end of today's class, you guys will be very much comfortable with these concepts of whatever I trying to highlight here. Okay, so let me start things step by step. Okay, so what I'm going to do today, right now, at this point in time, I'm going to show you the same command what I showed you yesterday. Okay, so for this, because there will be a lot of things I want to do in the file, so what I'll do, I'll go to my document folder, and here I'm going to create one folder called cryptography PHY training 22. So all the commands or any file whatever I need in this training today or my upcoming classes, I keep on posting in this folder. And this folder I will share with you if you need to share any data you have to share with you. So this folder is empty right now. Nothing is there. I'm going to create one file where we use the notepad to create a file. Let's say this is my plain text file. Okay, and this file has the plain text. Okay, and I said this is my secure data. I'm putting here my CVV number, my account details, my password. Okay, all the things there in my file. Okay, account. Okay, so let's say for us with this very critical file, and I don't want to keep this file in my local hard disk in this way, or I don't want to transfer this file over the network in this plain text. So I have to convert this file into secure form. That's called encrypted. That's called cipher text. How? I showed you yesterday already. Okay, so here I'm going to use OpenSSL command. OpenSSL command over here. And in the OpenSSL command, guys, there's a multiple options we have, or multiple things OpenSSL can do for you. What all the thing OpenSSL command do for you, for to know this and if you want to know this, just click enter. You will open to an OpenSSL prompt, and if you run the help command, you will see all the things OpenSSL support. Okay, so there's a lots of things OpenSSL support. Yesterday, guys, we used one command called encoding, but it's not encoding, I guess encryption. Okay, apart from this, there's lots of options, guys, OpenSSL has. Okay, for example, RSA, or for example, Gen RSA, for example, Gen DSA, X549. That's what we will discuss in upcoming classes. Okay, so they can do multiple things. As we progress, I will keep on explaining to you. Okay, but yesterday, guys, I used this command encode. So OpenSSL main command, or encode or encryption is the right term, I can say, is the sub command of the OpenSSL. Okay, now let me again quit from this tool. Okay, let me use the encryption command, and you can see the help command I showed you yesterday to see the help what they support. Okay, so let me do one thing. I have to encrypt something. For this, we have multiple. We can see the list of the cipher. We can use this command or this command, same command. Let me use cipher command. It will look better. Okay, this will tell you all the algorithm it's supported here to encrypt. Let me use the same algorithm what I used yesterday. Okay, this algorithm, or maybe I can use this keyword here. Okay, so this is the keyword I'm going to use to encrypt. This is the exact same command I'm doing right now. Just for some reason, I'm going to explain you very interesting concept in a minute. So I'm using this command to encrypt is encrypt. Then I'm taking an input file, okay, my plain text, and going to output other file as a secure.txt. Okay, so that's all. So they are asking password, guys. Now this point is very important. Okay, when they're asking you password, guys, this concept is known as master password. Okay, so there's one concept called master password, there's one concept called master key, and there's one concept called sub key. Okay, what are these? I'll tell you in a minute. Okay, but let me type my master password. I'm typing some password here, and my file has been encrypted. So if I run the CR, this file has been encrypted. I showed you yesterday about this file is encrypted. One small thing, if you notice here, my actual file size is 39 bytes, but after encrypt, it becomes 64 bytes. Okay, so guys, there's 2 or 3, 4 points to be noted in the screen, and then I will go more deep into this command today. So first, when I use this encryption, symmetric key encryption algorithm, AES 256, here they give me 3 terms: AES 256 CBC. Okay, so AES here is cipher name or the algorithm name. Okay, 256 is my key size, or I can say, sorry, master key size. And CBC is the mode, cipher mode. This is the mode I was talking about. This CBC, cipher blocking chaining mode. Okay, and second thing, guys, here is when you type this password here, this password is usually known as master password. You know, the master key is a master password. Okay, now what happened? Okay, whenever you encrypt any file that is actually a data, okay, and the way I explained you yesterday, right, how it encrypt. Okay, so when you encrypt any data that come from the file, obviously, when you encrypt any data, while encrypting, okay, it convert into ciphertext. Okay, to convert in ciphertext, I show you yesterday this some kind of way and some kind of key table we use. Okay, and who create this key table? Who help you to create this key table? For this, we need some key V. Okay, you know, I showed you yesterday, A can be converted into I, B can be converted into J. It's called mapping or key mapping, or I can say key table. Okay, yesterday I showed you this substitution method here, the older technique. Okay, but today's all the cryptography encryption is based on these kind of method only. Okay, so this is what I explained you yesterday. Okay, So this key is the one who help you to finalize this kind of some concept behind this, and that we'll discuss in a minute in very detail. This key will help us to convert this plain text into the cipher text. And again, you want to convert it back. Again, you need this kind of key or this kind of table who will help you to convert your data back. This is called encryption. You guys know this is called decryption. You guys know. Okay. So the key that is helping you to do the encryption or the decryption, we are using both the same key. It's called symmetric key. This key is called master key. Or I can say this table, what I explained you yesterday, is like a master table. Okay. Now, this key, guys, is not this one. Okay. The password that you type is not actually this key. Okay. Whenever you run your OpenSSL command and you give your algorithm name, okay, behind the scene internally, randomly they create one key for you. Which key? This master key. Okay. And this master key is the only one who has a capability to encode or decode. Okay. But to safeguard this master key, okay, because if somebody stolen your master key, the master key is again like a data only. The key may be A, B, hash, 1P, something like this. Okay. But if somehow you stolen your master key, get somehow your master key from your operating system or from your program from here, right? They will get the access of the key, and via access this master key, whatever the cipher text they have, they can unlock it, decrypt it, and can see the right data. Okay. To protect your key, we also lock this key with some kind of other key. This is called password. That's called master password. So master password is also only helping you to safeguard your actual internal key. Okay. But this password is not at all useful to encrypting and decrypting this data. A lot of guys think we are giving the password here for encrypting. No. Okay. Actually, this password is only helping you to safeguard your master key. And this key is the one who is helping to encrypting and decrypting your actual data. Okay. But where is the master key? So whenever you run this OpenSSL command, any kind of this program, internally they created this key randomly. Okay. So if you want to see this key, how this key created, how the key look like. So I have one command for you guys that will tell you how this key look like. Okay. How this key look like. But whenever you use this command, this command, this one, to decrypt. Okay. And I want to decrypt my data from this file. That I show you yesterday. Okay. This command asks a password. You know why they're asking this password? Because they would like to unlock your master key. And this master key is the one who finally going to decrypt your cipher data to the plain text. So if I give my master key here, so master password here, okay, internally they unlock your master key, and master key is the one who unlock your data or decrypt your data. Okay, this is how. But if you want to see how your key look like, master key look like, so in OpenSSL, okay, if you see the help of the OpenSSL, and here they tell you the specific command. For example, in my case, I was using this particular algorithm behind the scene. So they have one specific command for this algorithm. If you see here, this is the one or this is the one. Okay, so let me take this command. Exit from here. Now this command, right, has the option, okay, because internally the algorithm is this one only. They are the one who is generating your internal random master key. Okay, so we can directly connect to this program, and let's see if I ask this program, can you tell me as a help, what can you do for me? What options you have? So I have the multiple options. Okay, one option I'm looking for here is print my key. Okay, so if you want to print your key, actually we can use P capital option. Okay, so here I use this P capital. And now when I run this program, okay, by default, they're asking me to give the password to safeguard this key. Okay, that's the only reason. So let me give some password here. Okay, but technically what they print, they will print this key. This is the critical key or critical data you have. This is how guys your key looking like. This key, what I was talking about, key look like, master key. Okay, and this is the one that is the responsible to encrypting and decrypting the data. So if you have anybody has this key, they can directly encrypt and decrypt your data. I'll show you how by using this key. Okay, this is one thing. Second thing, there's one more concept called salt and IV is initialization vector. You know, guys, I was talking about this IV here. Okay, this is very important concept. I will explain you in a minute. Okay, so key, at least technically understand what is key, what is use of salt and IV. We will discuss this sometime. Okay, but whenever you're using any algorithm or the latest new algorithm, they use salt or the IV with the key to do something else. But key is the main critical area. That's what I would like to emphasize here. But if you notice here, okay, this key, okay, is this much in size. But if I use other example, for example, I say the OpenSSL, and if you go and there's some other algorithm also available. This one is available, or ID available, or this one available, right? So if you search, if you use for example this one DES, okay, and if I run this command, same command, if the support, let me use DES. Okay, again I'm giving the password. Now, if you notice here, again they have the key salt IV, but the key size is very small. If you compare this key size, it's very big. Okay, but this key size is very, very small. It look like, guys, there's nothing big difference here. Okay, but the technically this difference is very big. Okay, typically here, if you convert this data into you know, bit or bytes. Okay, so this number is around 56 bit. This number 56 bit. Okay, or this number, if you talk about, they are 256 bit. That's what the number 256 come from. It means if I go for this algorithm, okay, this one, that also we have 128, is 128. Here this key size is smaller. So this key size is 128 bit. Mostly all the bank and financial organization, if you see, normally they give the stamp in the website that we are using 128 bit key. This is what the size of the key they're using. Okay, but if there is a 512 also, by the way, there's no support in this system, but we have 512 also available, but it's not there in the system, or maybe some other options they might have, or maybe not have. They don't have. Let me check. 512 by chance is not there, but it is also available in the market. Okay, the point here is, okay, by looking at this number, okay, for example, if you go to DS, their key size is 56. So DS is one encryption algorithm, symmetric encryption algorithm. We can again encrypt your file with the DS, the way I show you how to encrypt, decrypt, the same command. Okay, but this key size is very small. Even though if you search for DES encryption algorithm, okay, you will see somewhere the size of key length is 56 bit. Okay, now point here is what is key. Okay, key is the one who is actually finally encrypting and decrypting your data. It means if you know the key, okay, you don't need any password to encrypt or decrypt your data. So let me show you one quick demo for this, that key is enough to encrypt and decrypt, and then remaining concept you guys can understand very quickly. For example, again, I have this file. Okay, I want to encrypt this file. Okay, so same command, OpenSSL, I can use. I want to encrypt, and for encrypting, let's say I want to use AES algorithm, maybe let's say 128. Okay, key size. Then I am going to use E options to encrypt. I would have to encrypt this file. Okay, and and I want the output maybe here, and let's say c.txt. When you hit this enter, your OpenSSL command, guys, randomly create a key for you. That's what I was trying to show you in the last command. So every time, let me again hit enter. Randomly, guys, they want it. Okay, internally they reuse this command. Okay, and randomly, guys, they create this key for you. So, guys, this number is 7600 something 6D. When again hit, now it's become different. Randomly, they create this key. Same thing when they run this command, they randomly create one key, store somewhere. Okay, and this key, they help you to encrypt this file. But if you don't want to use randomly and you want to encrypt your file by your own personal key, okay, there you can pass the option have one key. And you can give a key name, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the key I'm using. So what I'm trying to tell you guys here is password we don't need to encrypt the file. We need the master key. They are the one who encrypt or decrypt the file. Okay, that's what I'm trying to tell you. Okay, password we all extra put here to safeguard a key. Wherever the key is storing my local system, temporary file or temporary locations, wherever they're storing, I want to safeguard this key. That is the only use of the key, or use of the password, I can say. Okay, so guys, here there's one error come up. If you want to give the key, you have to give the IV also. Okay, what is IV? We'll discuss in a minute. Okay, but let me give the IV. I'm just giving IV some random number here. For example, maybe A, B, 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 something I'm writing here. Okay, there's some kind of warning come up because I give the key size very small. Okay, it's just a warning. The key is very small. They use padding. What is padding also we will discuss today. Okay, but technically my file has been encrypted. If somebody try to read this file, nobody can see it. It's like purely encrypted, right? Okay, this is how ciphertext look like. Okay, and this is how your plain text look like. Okay, but if somebody want to decrypt your file, okay, how they can decrypt? They can decrypt with the D option, obviously. Okay, they can give the input file name is this one. This is the my ciphertext, and they can decrypt. And now for decrypting, guys, if anybody know about your key, okay, using this key they can decrypt your data. See here, data come up, right? Okay, so I'm trying to prove you password is not required. Key we need to decrypt. Okay, key we need to decrypt. Now this key size is right now I'm taking very small, but the key size you can take till 128 bits. Key total we can take. Now point here is, let's say we are the hackers, and we want to break the key. I want to unlock this file. Okay, the only thing I don't know, let's say, is the key. So how can you break the key? Okay, so how can you break this password? How can you open this file? Okay, first we try with key 1. They're giving the wrong bad decryption. Then I go here, let me put in the last. Then I can type case capital here 2, not working. Then 3 is not working. 4 is not working. 5 is not working. 6 is not working. Right now I'm doing it manually, but you can write any programming language and put the loop. Okay, and try 1, 2, 3, 4, 5, 6, 7, 8 like this. Okay, keep on doing, right? And as trying all the combination till 128 bit. Okay, you know, guys, how much 128 bit is 2 to power 128. Means around 2 to power 120 combination to write. And what is 2 to power 128? If you type 2 to power of 128, okay, this number in the decimal is this one, e to power, I mean 10 to power 38. Okay, it is so big number. It is so big number. Okay, so big number that if you use a current existing supercomputers, okay, it takes thousands of years to do this hidden trials. Okay, again I'm repeating, if you take the one of the super fast supercomputer in this world exists today, and if you run this computing hidden trial, okay, by the way, this hidden trial is known as brute force attack. So if you do this brute force attack like a hidden trial, okay, and run this program not by yourself manually in the in the some kind of supercomputers. Okay. Okay. To do these many calculations, roughly these many calculations, to come up with a final key, it takes thousands of years to break it. Okay. But if it's 2 to the power 56, okay, this is very small number comparatively, right? It is a big means a very small number comparatively, okay, to 2 to the power 128. Okay, and this number is so small, and because by chance this key length is available in DES. DES, if you guys see here, the DES, what I was talking about is again symmetric algorithm, but this key length can be stored. The maximum key length is 56 bit, and this number is so small that not today. Nowadays the computing power of computers, and we have cloud computers and a lot of computing power, CPU, GPU we have. Okay, but in 1998 around, okay, somebody has created one machine, and in this machine they create this algorithm, okay, within 56 hours. That's all. Okay, so if you search here in the market that DES cracking online or maybe machine, so somebody created this machine long back, DES cracker machine. Some you can see somewhere some page also how this machine look like. Yeah, this is the machine actually we're talking about. Okay, and this machine, that time the cost is $21,000 $250,000. Okay, price is very high, but within some hour, maybe they're written here because it is 56 bit, within some hour, around 56 or 60 hours maximum, okay, they break this key. Okay, break this key. Now again, it is not important the price is very high, because if this security come as the national security, for investing this much amount for any government is not big deal to break some code. Okay, so compared to the price is very, even though they create this chip long back, maybe in 1998 around, but I know, you see the history around 1998 to 1999, they create this. All right, it's 56 hours actually. Here it is. They break it. Okay. Now in today's machine, the machine very faster. Maybe some second we can break it. This key. Okay. Even though there are a lot of online tools also available. So my point here is, okay, my point here is the big game in the encryption algorithm is the key size. How big your key is. How big your key is. Okay. And that is the reason, guys, DES is using very small key size. And this can be break very easily, very fastly, very quickly, I can say. So we don't use DES algorithm. We don't want to use DES algorithm. Okay. We want to use an algorithm that is giving a bigger key size. So AES is the one of the algorithm that give us options to use 128-bit key, 256-bit key is very powerful, right? AES and encryption algorithm. Okay, or I think 512 also now the new version of 256. I think 512 also they supported, maybe not listed here, but it is supported in AES algorithm. Okay, so it means if my key is being created is 256 to 2 to the power 256 combination you have to try, and the biggest supercomputer in the world won't break it for thousands of years. Okay, and if I'm the hacker, I can't live thousands of years, guys. Even though I don't have access to supercomputer, so if I have the supercomputer access, so why I need to break the key? I'm itself myself a rich person, right? So we don't need to be to hacker also. Okay, that is a one important point. Just to give you extra knowledge, to give you curiosity about something, right? And so one interesting thing is I'm just giving you extra knowledge apart from the cryptography classes. Okay, it means AES is the one of the top security encryption symmetric encryption algorithm we have. Okay, even though 128-bit is enough also, and mostly all the banks you see in there some stamp and somewhere this is the very commonly thing they always write that this level of security we use. So seeing all the transaction of banking, all things, they're using this level of key. Okay, and because they know to 128 means 2 to the power 128 combination around, they have to try to break the key. Okay, and I told you guys none of supercomputers can break it. But okay, there's one more computing power, guys, has been come in this today's world of IT. Okay, I think you guys might heard about this called quantum computers or quantum computings. Okay, these guys is this is the guys current and future, right? I highly recommend everyone to go. I learned the quantum computers, and recently, guys, I think some month back, I have delivered this very advanced training in the quantum computers or the quantum computings. But this, with the help of quantum computers, okay, if if you want to break any encryption algorithm that might take thousands of years on the world top supercomputers, same algorithm, for example, we talk about this one, or maybe 256 to 512 bit key, okay, same level of encryption can be decrypted in the quantum computer within some minutes or seconds. Okay, that is the power of the quantum computers. Okay, the only thing is it is not available for public market. Otherwise, you can see a lot of damage happening across the world or the internet. It's been they are in some research company, they're doing some research, not been connected to the public world. And there's one more concept called qubit. They have a limited qubit also, but when they have a more qubit, then breaking this level of key will be very, very easy. And that is the reason, guys, all the big top companies or countries like China and XYZ, they're working hard to make their quantum computer more and more quickly come to and connect to the internet, right? But just want to give you this information, and they have one algorithm, Grover's algorithm. Grover's algorithm one who can do this thing with the help of quantum computers. So it is proved, and I also, guys, proved in my quantum classes. When I deliver this class, I use the Grover algorithm. I proved to break something, and within a quick they break it. But I just want to give you extra knowledge. Even the Grover algorithm and quantum machine is not available publicly on all the internet, but using this algorithm, not the Grover, I can say Vajirani or this algorithm, right? Grover is for searching, I'm so sorry. So Wostrin, Vajirani, or this kind of algorithm are some of the algorithms we use to break this thing, right? So very quickly, just we're going to give this information, nothing very special. So in the quantum computers, if you see maybe in some Wikipedia article, okay, and somewhere you may see in history some timeline, right? Just wanted to give you this information that is also possible. Okay, so 1 minute. They give you this detail. I don't know what is the link, right? So quantum computer timelines of the quantum computer, maybe. Okay, over here you will see this is the journey of quantum computers, and here in this journey, and what you will see, if I can quickly show you the timeline. Okay, so this is the one thing. Here you will see 1 minute, very quickly, millions of times calculation you can fastly run. Here you can see one link that has been also been proved with the help of quantum devices. They break the one of the biggest powerful secret key that biggest quantum computer weren't able to do it, right? So there's one link, and that's also I show you in some of my classes of quantum computers, right? So I don't know what is the link. So I don't want to invest the time, but but this is what is there in the timeline. It is also written. So let's come to our main point. But let's say till the time quantum computer is not there, our internet is very, very safe. When the quantum computer come in the world, then we have a different kind of algorithms come up to safeguard the remaining point. I'm actually very curious to just show you that part is very, very interesting. I don't know where the link goes or the theme goes, but they tell you. Okay, I'll show you maybe next class. I'll keep on open this link and show you. Okay, but let's forget about quantum computers. But so what I want to do, guys, give you this curiosity that there's a future. So it's good, very good right time to learn quantum computers in detail. But let's come to our main point. Let's talk about AES. So this is one of the super powerful algorithm available till date. Okay, AES 128.1 or 256, right? Now, point here is, guys, it is also not about power or how powerful you are as a key size. Okay, it is also about how faster you are. Because if you want to encrypt or decrypt, okay, any data, okay, every time you want to encrypt or decrypt, because like in the normal internet transaction, every packet is going keep on coming and going. Every time you have to encrypt or decrypt. Okay, and if your algorithm is taking a lot of time in the terms of encrypting, decrypting, okay, it will slow down the entire process. Okay, it will impact the performance. Okay, it will increase the time of accessing application. Right? For example, if you access Facebook, you post something, get some data. If everything slow down because of security, because we need security, right? If you need encryption, but if your key size is very bigger the key size is, slower your encryption would be or decryption would be. Okay, so again, that is one of the reasons why we don't need much bigger size of the key or the key size. Okay, and that is a one big difference between AES 128 algorithm and DES triple DES algorithm. Okay, so DES, guys, I have told you already, is very small key size, but we have one more algorithm called 2DES. This is called double DES. Okay, and 3DES called triple DES. So I don't know, we have 3DES here is not supported. Let me check. Triple is not supported, but let me show you. We have a triple DES also available. This one. DS2 also there, but they don't have. There are some other kind of security issues. But DS3 is again a great powerful algorithm. Okay, so one good thing about the triple DES or DS3 we normally write. Typically we say triple DES or triple DES. Okay, if you see, guys, this key size is very big. Again, typically 3DS means by default DS is 56 bit in size. 3 means into 3, 56 into 3, whatever the number come up, maybe I think 168 around. Okay, so the key size is 168. It means they are bigger than AES 128. So this key size is 128 bit, and this key size is 168 bit. Okay, but technically this is more strong because this key size is bigger and this is less strong comparatively, per se. Okay, but even though we prefer this a lot in the real world because of a lot of reasons, one of the reason is compared to size is a little bit smaller, but this is a technically very bigger if you talk about brute for attack perspective. Okay, so this algorithm is considered very fast algorithm, and this is considered as a very slower algorithm. There's one big difference. Okay, so mostly that is the reason we don't use triple DES in the market. This is one of the reason we have, because the key size is bigger. That makes the DES or DS triple DES DS slower. And AES 128 is very powerful. I told you the calculation already, 2 to the power 128. Okay, but this key size 120 is very logical, so that makes the things very fast. So that is the reason, guys, almost all the internet communications, mostly where you have a lot of data transferring here and there, mostly we use AES 128 bit. This is one of the reasons. Other reason is how this algorithm created. Okay, so DES, guys, has been created. If I show you the I think some article was open that point in time. So that was a global, we go for different thing. Okay, so this is a different algorithm for encryption in the quantum computer. But if you talk about AES, AES, guys, is created on a concept called substitution permutation network, and DS created with the idea called facial cipher idea. Okay, so they work on the different idea, different concepts. Okay, and this concept is comparatively very slow instead of substitution and permutation concept. Okay, I don't want to go more deep into this. Little bit I'll give some idea on this point, this substitution permutation and the facial cipher concept. But what I'm trying to tell you here is your DES algorithm, maybe triple, double, or single DES, right? This work with the concept called facial, how you pronounce, concept of facial algorithm, I can say. AES algorithm is super fast, super secure also, and super fast also, because they work in a very different algorithm. And this algorithm substitution hyphen permutation, let me use the SUB hyphen permutation network algorithm, that makes this algorithm competitive not is very fast as compared to this one. Okay, and that is also one of the reasons why I use AES. So AES one algorithm very harder to break. Till now, there is no break available in AES in the internet, and this is also super fast. Okay, but triple DES is very slow, and there's a lot of chances depending on how you manage your data. There's a possibility. Okay, we might break triple DES. Is on the SS not proof available, but depend upon how you set up the entire architecture, there's a possibility it might be break. Okay, but there might possibly there's a paper on this, how to break this key in today's infrastructure of the network or the computers, but there's no proof available in the internet to break this key. Okay, so let's go deep into the DS and the AES to understand this thing, and that will give you what is a block cipher, what is stream cipher. Okay, and they also give you the padding, IVs, and all those concepts. Okay, what I was trying to explain you here. And they also give you the optional meaning of these modes. Okay, so I think this is, I'm just trying to set the basic context. So let's go back in the history and try to understand, okay, how we reach to AES. Till now, what I explained to you, AES is the one powerful algorithm and fast algorithm also. Okay, in the symmetric key. Guys, I'm only talking about symmetric key. Asymmetric key we might start tomorrow. Okay, so let's go to the history. Okay, so guys, I told you yesterday, long back we were using the substitution cipher algorithm. What are this? I told you yesterday, A can be replaced by I, B can be replaced by J, and something like this. So this was the very long back, but this is the basic of the modern algorithm. One of the modern algorithm is very powerful. It's called AES. Okay, so AES, guys, I told you they work in a concept called substitution. Okay, this is one of the idea behind AES. But there's one more algorithm, guys, that was using a lot in the past. This is called transposition cipher algorithm. Okay, what they do, if you want to send any data, for example, hello, I want to send. So before I send this plain text, I will convert it to cipher. How? I will transpose my data. For example, O I replace here, E I replace here. So I say O, then I replace this two character, L, then middle L, then E, then S, something like this. I do some transfer or transposition on my data. Okay, so I maybe replace first to last, last to first, second to third, third to fourth. So whatever the way you replace, that will be your key, that will be your algorithm, I can say. And then you'll go transpose. And wherever this data has been reached to somebody, okay, you will tell them this key or the algorithm that this is what the person change I have done. So just do the same thing again one more time, you'll get your original data. So this is called encryption and this is called decryption. So very logical, right? You can also create this kind of new logic by yourself. Okay, and one more algorithm, guys, we had a long back. That algorithm, guys, again in the history, okay, that has also been used a lot. Okay, that's called Caesar, or how you pronounce again, Cipher algorithm. Okay, again the same way that if one king want to send some data to the other king, right? So they say if they want to send hello, okay, so they use this algorithm. Okay, so what they do, this algorithm, guys, is a kind of shift algorithm. What I mean is, for example, I have A, B, C, D, E. This is data I want to send, and we have an English character 26, A, B, C, D, E, F till Z. So this is what the English characters we have, right? Okay, so what we will do, if you want to send this data A, B, C, D, E, for example, okay, so I will shift my data. For example, A, I will shift to 3%, for example. So instead of A, I will send D. B again I shift to 3%. So D would be E. C, I want to shift to 3%. Wherever they are, it becomes F. So this, guys, they're using the idea called shift. They are shifting your data. This is called shift algorithm they use behind this. So Caesar Cipher algorithm using shift idea or shift algorithm, and whatever data on, say, for example, H would be shift to the H, I, J, K. It can be represented with K. E, they shift to 3%. I had E, F, G, H, something like this. Okay, now they shift with 3 or 4 or 5 or 10, depend upon how they want to shift. Okay, so wherever the data reach, I'll say again shift back to 3%, you get your data back. So these are the, guys, older, early, very older algorithm we had. But I'm giving this information so that all the new algorithms, okay, is using this kind of idea plus add a lot of new extra complexity, okay, to the things. For example, if you talk about AES, they again using substitution algorithm. They are substituting with something, the way I explained to you. Okay, plus they are also using something idea, not exactly of Caesar, but like they are using permutations combination. For example, any data I want to send, for example, ABC, this was my real data. Okay, so they will create a multiple permutation combination. Let's say one of the combination may be B, C, A, one is C, B, A, one is C, A, B. So these are multiple permutation they create first of the original data, and randomly they will use one, or maybe have some kind of plan that whatever permutation come up, they will pick the second one. Okay, and then they do things together, then do some more thing. I'll tell you in a minute. Then they send the data. Okay, but before I explain you AES, furthermore, okay, I have to explain you what first Fiestel algorithm, and then give you a lot of next explanation, and then I will move back to AES. Okay, even though again, guys, if you don't know about this concept or what I'm trying to explain you, Fiestel algorithm or substitution permutation network algorithm, older one, you can work with this command to encrypt, decrypt the things, right? And this logic is enough. Key is bigger, it is not hackable, smaller, it can be hackable. This information is also enough, right, to work in cryptography as a practical perspective. But I told you yesterday, if you don't have these detailed knowledge, what I'm trying to explain you in a minute, then it will be impossible to choose which one to use. It has been very clearly said in a lot of cryptography world that why we need this, why we have so much thing, what is use of this, what is use of this. And a lot of guys use randomly. I told you guys, if you use randomly any of this algorithm, you feel a lot of issues. It look like we encrypted, but we don't know the concept. Either your performance degrade, either it look like you encrypted, but it not encrypted the data. Very interesting example I'm going to tell you. You will be, blown away. Because when I say encryption, it look like encrypted. Nobody can read it. Nobody can get the data. But if you're using the wrong encryption method or the mode, thing won't work the way it should work. And that is again one of the challenges in the network security and real world security, that we feel we encrypted, but it not encrypted actually the way it should what we need. I'll tell you one interesting example, and that is one of the big reason a lot of things nowadays you keep on listening about cyber world, cyber security thing is breaking. So it's about the game that you know how to play well, right? You don't know how to play well the game well properly, it won't work. Okay, so now guys, I'm giving a lot of basic idea of some terms here. Then let me move to the next part to explain you Okay, some other details, then I come back to this point. Okay, so right now what I'm going to explain you, okay, one small thing. Whenever you use any symmetric key encryption, okay, there's a lot of encryptions available, or encryption algorithms available, cipher available. Okay, symmetric key I'm talking about. Behind the scene, they use some kind of way, some kind of mode to encrypt or decrypt the file, or the data, I can say. Okay, let's say they want to encrypt this file. Okay, what a file I have. Right now, file size is 39 in bytes, right? So when they encrypt or decrypt, what they do? Let's do the one small thing. Let me make this file a little bit big. Okay, I'm just putting some data here. Maybe random, but we can see some data is there. Let me write my name. So look like a plain text. Let me put my company name, Linux World. Plain text. So this is the data we have. Let me say the size of this file. This file is around 111 bytes. Okay. So what happened? Okay, when you try to encrypt this file, plain.txt, this file. Okay. Now guys, file size normally in kilobyte and megabyte or gigabytes also. Let's say my file right now, file size is 111 bytes. Okay. So whenever you guys use any algorithm, okay, to encrypt the data, okay, mostly the algorithm guys don't take the entire data in one go. Okay, they don't take this entire data in one go. They take the data in a chunk. It's called block. Okay, and their block size is fixed normally, always. Okay, let's say the block size is 64. They take the data in 64 size. Means they take only 64 bytes in one go. So file size 111, but out of 111 they take initial 64 bytes data. Okay, and then they take next 64 bytes. Okay, right now my file size 111 only. So if we got a minus 111 64, so I think 36, 46, and maybe remaining would be, I don't know what I'm doing. So 36 plus 11, 47, right? I think this might be the right. 47 bytes. Okay, so this plus this is what 111. So they divide this file in two parts internally. This is known as block. Okay, where I consider my block size is 64. So let's say I'm just taking as an example, maybe 32, maybe 128. Okay, and now for us, this is one big file of 1 GB or 2 GB. But technically, any encryption algorithm, they take one block. So block number 1, let's say block number A, block number B. And for the encryption, now this is the data. Okay, and they encrypt this data. Okay, as this individual. Then again, they take next block and they encrypt this data. This is how guys almost all the encryption algorithm do. Every encryption algorithm has different block size. Okay, block size. For example, if you go for DES algorithm, DES algorithm in the cryptography, you might be see somewhere they are using block size. Maybe somewhere you will see in some Wikipedia article somewhere. So they might be have block size, let's say 64 byte. Okay, you can check there. So what a block size they are picking is 64 bytes they're using. Key size is different. Keys is, I told you key, but this is the block size they're using. Okay, but if we go for AES, I think the block size is 128 MB. Okay, so if you see the block size of this guy is 128 MB. Block size, key size different. You guys know. Again, don't mess. Means they're two different concepts. There's a block size 120 byte. Okay, but typically most of the algorithm they have the block size 65. Okay, and idea is simple, guys. Smaller the block size is, it takes more time to encrypt. Okay, so for example, your file size is let's say 640 bytes. So 10 blocks to first create, then every block to encrypt. Take more time, obviously. Okay. But if your block size 128, maybe just having 5 blocks only, it would be great. It would be encrypted. Okay. So again, blocks also matter in terms of performance, because again, guys, I'm not only talking about the break. First important criteria is my algorithm won't be breakable, right? For us, the most important thing is data. So this is our main criteria. I don't want it to break. But second criteria is performance. I want the things to be very faster. The second criteria or property we need. Okay. So what I'm trying to tell you here is every algorithm is working as this one. They will create a block. That easy reason. Okay. Symmetric key encryption are normally known as block encryption or block cipher algorithms. Okay. Block cipher algorithm. Okay. Or I can say any symmetric key algorithm is divided into 2 parts. Okay. One is called block. Means they will create a block, then block and block. Every block they encrypt. Okay. But there's one more type called streaming. What are this? I'll tell you in some minute. But there's some algorithm that will work on the streaming. Okay. And good use case for streaming is the live. For example, right now, guys, what I'm talking to you, my data has been encrypted. Okay. And my data is encrypted in the Zoom meeting. If I'm using encryption here, I think Zoom are using behind the scene. Very quickly, I will check with Wireshark. Wireshark, can you tell me my Zoom meeting is going on? My data, my voice, my audio, video is going over the internet. So what do you think? What do you think is going? I don't use no here. Is going. 1 minute. Because this tool requires a lot of admin privileges, a lot of things they're doing. So can you tell me, let me start capturing. Can you tell me my Zoom meeting live going on here? I think I'll give one limited privileges here. So nothing is coming. Okay, I'll show you this tool yesterday already. Let me again go back to capture because I give a lot of access denied in my admin mode. Okay, I saw you guys yesterday. I saw you a lot of traffic was coming. Actually, I stopped a lot of admin mode here or the permission, so traffic is not coming. But if you see here, okay, if you see here, or maybe that, let's just forget about this tool for some time. Okay, but if you see here, my live Zoom or live streaming, my data is encrypted. Internally, they're using streaming. So what is streaming? We'll discuss in a minute. But right now, let me focus on the block. Okay, so if you see any algorithm like AES, DES, okay, they will see they are block ciphers. Okay, there's 2 ciphers. One is streaming also. We'll see in streaming somewhere. Okay, now there's some term I was going to give you. Now let's talk about next point. Now every encryption algorithm mostly they're using creating a block of the data and then encrypt every block of that big file. Okay, finally this encrypt data, let's say whatever data will become, let's say ABC come up, let's say this XYZ come up, then they add together and store in one single file. Okay, so if you see here, okay, we give this, let me again encrypt one more time. We encrypt one more time this data. 1 minute. This data, right? Or let me use without key, they will auto generate and store in this file, let's say o1.txt, or I may give o1 AES 128.txt is the file name I'm giving. Okay, 1 minute. What I give, so it's like encryption, right? So this data has been stored over here in this file. Okay, now why they give the lesser size? There's a one compression also they use behind the scene, right? There's a different point, but they store here. So they take 64 byte, then take the main part, then they add together and store over here in this file. The point, guys, here what I'm trying to tell you here is, okay, by default, let's say in your file you have a data. Let's say my data is hello. Okay, then again hello, then hi, again hello, again let's say my name Vimal. So this is the data in the file. Okay, this is one big file we have. Okay, now what happened, guys? Understand this concept is very, very interesting and very much powerful also. Okay, now in this concept, right, what happened? Let's say this file, what the size would be, they divide this file into multiple blocks of let's say 64 bytes. And just for example, let's say this is 64 byte. This also 64 byte. This also 64 byte till here because we have some spaces here. This also 64 byte. Then this also 64 byte. So 4 or 5 blocks they created. Okay, 4 or 5 blocks they created. Now what happened, guys? Okay, when this block created, this block is first encrypted. Okay, and let's say as an encryption, the output would be ABC's encryption data. This is a clear text. This is a cipher text. Okay, and here we're using same algorithm. For example, I'm using AES algorithm. AES is very powerful. I use AES, or I use a very powerful key size 128. I think it is a very, very powerful. Nobody gonna break it. Like that, I'm trying to tell you, is a even though we use AES and 128-bit, but it can be breakable. I'll show you how. Okay, so let's say this is the data we have. I use AES algorithm with 128 key size or 256 key size. I convert the hello into this text. Okay, then again I use same algorithm in this data or data chunk or data block. In this part 64 byte, again I convert because I'm giving same data, same algorithm, same key size. So obviously, if you're using everything same, your output gonna be the same exactly, right? Obviously, the way I explained you already, right? For example, the way I show you this, the old algorithm. Okay, this one, for example, where it was this one, right? Let's say A has been substituted with I, B substituted with J, C substituted with, let's say, M. So when the A comes, they always come to I. When B come, always they come to J. Similarly, whenever again same data come up, they will convert and blend into the same data. Okay, again ABC come up. Well, let's say hi convert into X by Z. Again hello come up, they convert to ABC. Again we will come up, let's say they convert to M and P. Okay, and now this is the real data we have or plain text, and now they convert into this one single file. Okay, they just show one single file continuing the same way, same order. Okay, of again 64 byte, this again 64 byte, 64 byte, 64 byte, 64 byte. So that is the reason, guys, almost you will see whenever you encrypt any file, the original file and encrypt file size is almost same. Sometimes they're lost a little bit smaller or bigger. What are these reasons? I will tell you. There's a concept of padding and the compression. So, but almost they are same. Okay, you won't find much difference in the file before encryption, after encryption. They're almost same. Little bit difference there. Why we also discuss. So there is encrypted data in the file. Okay, but right now, okay, the way we are encrypting, okay, the way we are encrypting is this example. Okay, we are only taking one block and encrypting. We're taking one block and encrypting. Okay, the good thing about this method is if your file have 10,000 blocks, every block we can take individual and encrypt it. Okay, and every block is independent, individual, alone. This block has no relation with this block. This is a different part of the file. This is a different file of file. Every block is individual. So what can we do? We can do parallel computings. Okay, so any devices you have, or supercomputer you have, or GPU you have that support parallel computing, or you have cluster, for example, if you know about cluster, right? Tons of computer we can connect together. So this part we can give it to a different computer. This part we can do different CPU. This part can be different CPU. This part can be different CPU. Depend how you create a cluster setup of high performance computer, SPC, I can say. Those who know about SPC. Okay, so one single file encryption or maybe decryption, okay, can be done in parallel. So this makes this process or this algorithm, what I'm trying to explain you, is super fast if you use the pad. Again, I was talking about the speed, right? I want my algorithm should be breakable. It looked like it won't be breakable because this AES, but I'll show you in a minute. It can be very easily break. How, I'll tell you, but it looked like very powerful in the performance. Why? Because the file size is 1 terabyte, 1 megabyte, 100 terabyte maybe. Okay, I want to encrypt the entire file or the storage, complete data. And if we got a chance to do the operation in parallel, right? Why can we do in the parallel? Because thing is divided into multiple blocks. Okay, every part of the file we can send to different CPUs, and they work in the parallel. And anything work in the parallel, obviously they are super fast. Very quickly, maybe let's say one block encryption might take 1 second, right? So if you first you encrypt this one, then this one, then this one, then this one, because sequence. So if you have 1,000 block, then 1,000 seconds going to take. The method that I use, that's called mode I use, is called ECB mode. Okay, this is the mode they're using behind the scene. Okay, I think electronic code back. No, sorry, code back is code book mode they are using behind the scene. This one, code book mode. Okay, the console I explained you, message divided into multiple block, and each block encrypted separately. Plain text, convert, ciphertext. Plain text, convert, ciphertext. This is what they're using, code book mode they're using. Okay, good thing is they can achieve parallel here, encryption doing parallelism. They can do parallelism. This is a powerful thing, very, very powerful. They can work, but the bad thing about this algorithm is, okay, is this part. It means if you hello data, they can give the same value. Same hello can come up, they give same value. Why is bad? Okay, I'll tell you one good example of this. Let's say, or let me even open one of my image here. Okay, where it is. Let's say this is my image. This image, guys, is readable or understandable also. There's a clear text I can say. Okay. And if I decrypt my image, okay, let's say this is my image. If I encrypt my image, you know what happened? If I encrypt my image, okay, so this image is very big in size. Okay, and when I encrypt my image, they again take 64 byte in size as a block. So for example, they take this part as a block, then encrypt. They take this part as a block to encrypt. They take this part as a block to encrypt. They take this part as a block to encrypt. They take this part as a block to encrypt. So what happens when they pick this part? Okay, it encrypted and it given new values. And every value, guys, in the image like a one color. What do guys value give to image? Because if you guys know about computer vision or image processing, okay, every value is a pixels here is like a data, and every data is one color. So when you encrypt this part, let's say they give a red color, for example. Okay, it means when you encrypt this part, because right now the color is here also black, color also here black. Again, they give a red color. Again, if I encrypt this part, because this part again similar to this part, so what they give you output, they give red color. Means this part was black, now it's been converted into red. Similarly for part, take this part, this part, this part, this part. Everybody encrypted means converted different color. Okay, so file image will be encrypted, but it won't lose any information. Why? Because we are taking block part, and every block part that has similar color or similar data, they are converted to same form. And guys, when you convert same form, pattern in this image will be intact. It won't change. Color will be different, but you won't lose any information or the pattern in this image. Okay, let me tell you guys one good example for this to understand. I already opened this link for you. Okay, there was one image of this one, for example, Apple logo. Okay, in this image, if you use the encryption, maybe DS or AES, doesn't matter, but if you use this mode, what was the mode I was talking about? This one, ECB mode, electronic codebook mode. Okay, and if you encrypt this image, okay, they take 64 bytes. 64 bytes is very small byte. Okay, everybody will change into different value. It become different color. But when the color change of this image change, you know, guys, this is what the method they give you. I'll share this link to you. You can do the same demo by yourself also. Okay, there's some kind of graphical tool for this encryptions. You can also download this kind of tool. But finally, your image, okay, after encrypt, when you try to open that image, it look like this. It look like this here. After encrypt. Okay, now what to say? Actual image was this one, right? Does my image encrypted? Yes. But can you lose any information? Answer is no, right? The data change, value change, go to different values. Every value in the image is like a color. Okay, but because every similar block going to give you same value, or because they're going to same value, so my final information and the image, the graph, or some kind of these data won't be loose. Okay, that is very, very dangerous thing. Even though you're using one of the best algorithm, AES with 128 to 56 key size, but if your mode is this one ECB, then you will 100% fail see this issue. Okay, it means if in the command prompt, if you feel that in OpenSSL, I want to use this particular encryption, AES, very powerful, 122. Okay, but if you use ECB, then we are gone. Okay, we feel we are doing a lot of encryption, but anybody who can see sniff my data over the internet, that I show you what I captures. Okay, and let's say AES this one, right? And they can see my actual information, images or video, something like this. Okay, and the guys seen a lot of things. We are using AES 256 powerful algorithm till my data, or some, not every data is work. It work on data, like the image is one good example for this. Okay, but maybe video is example, maybe some other kind of data is example. And they thought, why is breakable? Wow, how is possible, right, to see this data? Because it's not about the key size, it's not about the algorithm, powerful algorithm, faster. It is about the mode. Okay, if you're using this mode where I'm trying to explain you, or if you're using this kind of process that I'm trying to explain you, where it was the mode, then thing won't work. So that is the thing I'm trying to tell you. It is so dangerous, right? If you know cryptography, but if you don't know the modes, and mostly guys, okay, anybody who are great in security background or security field they're working, most of guys here from IT background, they have a good known maybe security guys. They don't know these concepts, and with the wrong implementation of these keys, mode, encryption mode, your data goes, right? And guys, data is everything. We can't break my some critical images or videos, some other data with data or something else also. Okay, but this is what guys want to tell you here. But this is one of the mode we have. And guys, that's what we have to, that's what I started this topic right today, that we have multiple mode, where I was written this name details. So one of the mode I explained to you, ECB as the mode. Okay, so let me go to the next mode. Okay, next mode that is called CBC mode. Okay, so CBC mode is the one who solved this challenge. What EC mode? EC mode is good. They are very faster because we have capability to do the thing parallel. But this mode has one challenge in some kind of data. Okay, especially image and videos that I explained you already. And this example is good. And anybody who know a little bit programming like Python, I'm also sharing one link to you. Okay, where how to get ECB algorithm in the Python if you want to try. So this one link I will share it with you. Okay, this is the Python code. Okay, through which you can create your own ECB, AES, ECB algorithm. Okay, and if you run this algorithm, same thing you can see with the algorithm. Okay, this image is encrypted in this image, but you won't lose the information. I'll share this link to you. Those who know Python, they can try with this code. Otherwise, in this training, we don't need any kind of Python or programming requirement.